All right, we've talked about even roots and we've talked about odd roots. We've talked about square roots, fourth roots, sixth roots. We've talked about cube roots, fifth roots, so on. And there's a couple different rules we have to be careful of when we have odd versus even roots. Now, if we have odd roots, there's exactly one real root when the root is odd. Odd roots of a positive number are always going to be positive, like the cube root of 8. The cube root of 8 is always going to be positive, positive 2. And odd roots of negative numbers are always going to be negative, like the cube root of negative 8 is going to be negative 2, right? Absolute values are not needed when we're finding an odd root. We don't have to worry about absolute values when we have an odd root. X's can be negative, X's can be positive, so our domain is all real numbers, negative infinity to infinity. However, we do have to worry a little bit when we have even roots. Remember, negative numbers do not have a real root if it's even root. We also have to worry about absolute values sometimes when we have an even root. If there's a variable and we're simplifying an even root, if our answer has an even exponent, then we should be okay. But if our answer of an even root has an exponent that's odd, if our answer has an odd exponent, then we need to make sure that we put absolute values on our answer. The easiest way for me to check is always to just double check by plugging in some numbers. Typically, -1 is the easiest to check. Now, when the root is even, your domain has to be bigger than or equal to 0. Your radicand, the stuff underneath your radical, can never be negative. It has to be greater than or equal to 0. Let's do a few practice problems one more time with all different types of roots: odds, evens, negatives, positives, to make sure we really understand what's going on. Maybe you can pause the video, look at these two examples, and try them first by yourself and see if you have a good understanding of what we've been doing. Then come back and see if you have the same answer as me. It looks like on example number 9, we're simplifying a whole bunch of odd root questions: fifth roots, seventh roots, and ninth roots. So if they're odd, I don't have to worry about absolute value. So that's one good thing off my list. So let's just try to simplify. If you look at example number 9a, I want the fifth root of 32. Ooh, that means I need to find what number multiplied by itself 5 times gives me the number 32. You might need to try a few things, or you might need to factor tree so you can break it down into 5 numbers of the same factor and see what number it is. But the fifth root of 32 is just positive 2. Now look below it. What about the fifth root of negative 32? Is that okay? Well, I should be okay because I have an odd root. I can have an odd number of negative numbers to give me a negative 32. So the fifth root of negative 32 is negative 2. Negative 2 times negative 2 times negative 2 times negative 2 times negative 2, 5 times is negative 32. Perfect. All right, but what about C? What if the negative is outside of the radical? So really, I want to figure out what the fifth root of 32 is and then just take the opposite of that answer. So the fifth root of 32 is 2, and the opposite of 2 is negative 2. So I ended up getting negative 2 again. Okay, what about D? D says, I want the fifth root of negative 32 and then the opposite of it. So the fifth root of negative 32 is negative 2, and the opposite of negative 2 is positive 2. You got to be careful with all those different negatives. All right, what about E? I have the seventh root of x to the 7th. So what quantity multiplied 7 different times, maybe I need another one, multiplied 7 times gives me x to the 7th? You notice that x times x times x times x 7 times gives me x to the 7th. So I can say that the 7th root of x to the 7th is just x, or x to the first power. It's an odd root, so I don't have to worry about absolute values. All right, what about f? F says I have the 9th root of t minus 1 to the 9th power. This 9th power means I have 9 of them. If I'm looking for what thing multiplied 9 times gives me the number inside, well then my root and my exponent kind of cancel each other out, right? We're going 9 steps forward to just go 9 steps backward. So really, I can just say that the 9th root of t minus 1 to the 9th is really just t minus 1. You can put parentheses if you want to, or you can leave them off. It would be the same thing, but you do not need absolute values because remember, it's an odd root. We don't have to worry about absolute values with an odd root. All right, but look at example number 10. Example number 10 has a whole bunch of different even roots, and that's when we need to worry. Remember, we need to worry if we have negatives underneath our even root, because that's not possible. And we have to worry that our answer, when we simplify, if we have variables, if it has an odd exponent, we need those absolute values on there. All right, here we go. The fourth root of 81. What number multiplied by itself 4 times gives me the number 81? I got 3. Okay, but what about right below if I have a negative outside? Is it okay to have a negative? Sure, as long as it's outside of the radical, right? I can figure out what the fourth root of 81 is and then just figure out what the opposite of that number is. Well, we just found out that the fourth root of 81 is 3, so the opposite of 3 is negative 3. And that's okay, as long as the negative isn't underneath our root. Like look at C, the fourth root of negative 81. What number multiplies 4 times to give me a negative 81? Well, that's not possible. I can't take 4 numbers, multiply them together, and ever get a negative number because an even amount of negative numbers is always going to give me a positive number. So in this one, there is no solution because that negative is underneath that even root. All right, look at D. I have the fourth root of 81x to the fourth. So this is where we start to add in some variables and we have to worry about absolute values. We know that the fourth root of 81 is 3. What's the fourth root of x to the fourth? Well, just x, right? But do we need absolute values? Well, if our root is even, we have to worry. And if our answer has an odd exponent, which it does, then we need those absolute values. So the final correct answer would be the absolute value of 3x on this one. You notice that no other problem had absolute values, so I can't put them if they're not supposed to be there, but I need to put them if they're supposed to be there. So this one has to have the absolute values in order to be true. All right, what about E, the sixth root of y plus 7 to the sixth power? You notice that raising to the sixth power and taking the sixth root should cancel each other out, right? It's an even root though, so I need to be worried about negatives. When they cancel each other out, the exponent I have left is a 1, which is odd. So I need to make sure that I have those absolute values so that my answer is correct. The sixth root of y plus 7 to the sixth power is the absolute value of y plus 7. Again, you can put the parentheses if you want to, or you don't have to, but you do need the absolute values on that one. Make sure you practice. Make sure you practice knowing all of those different rules for even and odd so you can make sure you get the correct final answer.